Okay, good morning, guys. A couple things. Thank you for answering that question. If you haven't answered that question, please go ahead and jump on real fast and do it. Just wanted to point out a couple of things that I wanted you guys to see. That as I move this, these two figures are not congruent, but they are similar. Is what we're going for. They're the same. I think about similar as being like on the computer screen versus the TV. If I have a show going on the computer screen, it's going to be smaller, but it's still the same show as I would watch on the big screen. Things don't lose their proportion. But the biggest thing to see here is that the angles stay the same. A and W are corresponding angles, and they are the same, but the sides are changing. And I can, if I go to 4, we can see how the sides change. 4 to 2, it's half. But if I grow this, 4 to 3, it's a third this, or 3/4 the size. And if I go down to the 4th, move down, it's 1. And so these are proportionate, and it's to the scale factor that we're looking at here. And that's what we're going to look at. So I'm going to kind of try to go through and show you guys some stuff. Try to make it as quick as possible here. So if I want to talk about these two triangles being similar, a couple things we know right off the bat. If I just say, hey, triangle JKL is similar to triangle PQR, it's still corresponding parts. So J and P are still corresponding, and the angles are congruent. But what we want to make sure we then see is that now, and so K to Q, L and R, but now we are no longer saying that JK equals PQ. We're no longer saying that, because that's not necessarily true. We're looking at a proportion. So I'm going to look at the corresponding parts, and I'm going to make a ratio. So I'm going to say JK is corresponding to PQ, that ratio. So if I take 6 divided by 9, that should equal KL divided by QR. And that should equal JL divided by PR. Notice how this is the smaller triangle on top, and this is the bigger triangle on bottom. That has nothing to do with which side it is. I just want to make sure that we always have the big triangle on the bottom, the small triangle on the top. You could flip it and always have the big triangle on top and the small triangle on the bottom. It doesn't matter which way we do it. We just want to stay consistent on which side each triangle is. But if we look at this, if I take JK and I take 6 divided by 9, KL is 4, QR is 6, JL is 8, PR is 12. Those all reduce to 6 and 9 both have 3. 3 goes into 6 twice, and this their third. These 2, 6, 2/3. This is 2, this is 3. And they all are equal to 2 over 3. This is our scale factor. So I have 2/3. Or if you went ahead and you flipped these around, you could say that it's 3/2. That's my ratio. I know that this PQR is 3/2 larger than JQL, and I know JQL is 2/3 smaller than PQR. That's the ratio between the sides, and that's going to be true for everything in there. So if I draw a line here to the midpoint, and then I draw a line here to the midpoint, those are going to be proportionate. If I take K to the midpoint divided by Q to the midpoint, it's going to be 2/3. It's the same throughout, and that's what allows us to use that. We're going to be using ratios for the next couple. Weeks here, and so we want to make sure that we know how to use them, and that's what we're going to look at as we go on to this next one. So I know that triangle EFD is similar to triangle NPM. So all the angles are the same. E is congruent to N, F is congruent to P, D is congruent to M. But then our sides are corresponding, are proportionate. So I know that 15 divided by 18 is equal to 20 divided by 24 is equal to X divided by 30. So what I need to do first is I need to find my scale factor, my scale ratio. So since I already know that, I'm just going to take some that I know here. So if I take FD, so FD, and compare that to PM, both those I have, and so I have 20 over 24. So now I can see that my scale factor is, I can reduce that, is 5/6. This is my scale factor. So now I can use that. So now I know that 5/6 is always going to be true, even if I'm looking at EF over NP. Now, why did I choose EF on top? Well, 5 is the smaller length, obviously. And so now EF's the smaller triangle. And so I'm going to put that up top. And now I can say that this one, I can actually put in here, NP is equal to 30. 5 times 30, this is in my ratio, so now we'll cross multiply. And I can come in here and say 6EF equals 150, giving EF equals to 25. So that is how we solve for missing side lengths in similar triangles. So let's try that one more time. I have these two triangles here. I lost it all. All right, well, never mind. We're just going to talk about area and perimeter then. So area and perimeter are the same idea. So let's look at perimeter. Let me change this. So perimeter, we now know that this length is 25. Perimeter is the length all around here. So if I take my perimeter of EF, so 15 plus 25 plus 20, I get 60. So I get 60, and if I compare that to a perimeter of NPM, I get 30 divided by, or 30 plus 24 plus 18, I get 72. And if I reduce that, let's see here, both of these have 2 in them, so I can come in here and I can say 30 divided by 36. And then I know both of these have 6 going there evenly, so that's 5/6. So it's the same ratio for perimeter. But let's look at area. If I look at the area here, let's just pretend, just for funsies, that these are right triangles. And so if I find my area of the first one, I'm going to take 15 times 20 divided by 2. That's my area formula. And I get 150. And then if I take this one on the NP, and if I take 18 times 24 divided by 2, I get 216. So again, let's do some reducing. So I know that both of these have 2 goes into them. So I get 75 over 216 divided by 2 is 108. Okay, not really quite sure what both goes into these two, but let's try looking at factors of 75. So factors of 75, we can look at being 3 and 25, and 108 divided by 3 is 36. So I have 25 and 36 are what I can reduce this to. Well, that's not that, but how is it related? Well, 5 squared is 25, 6 squared is 36. And so we come into this interesting thing where if I have just my scale factor for perimeter, my perimeter ratio is still equal to whatever my scale factor is. But for area, my area ratio is actually A divided by B squared. It's whatever my ratio is squared. So we can actually use that and making sure that we're squaring our ratio before we try to find the ratio, before we try to find lengths and area. This is actually one of the problems. You find the area ratio, and then you take the square root to get you the the scale factor. So if I have my scale factor and I have my area ratio, to get from my area ratio, my scale factor to my area ratio, I square it. And then to get from my area ratio to my scale factor, I actually take the square root. So that's what you guys are going to be working on. I attached the book that has some examples and everything as well. So feel free to look into those. The next assignments tomorrow and the next day it's going to be hard to do without discovery, and so I'm probably just going to be telling you guys what to be looking for and what to be doing, but it's going to be showing stuff is similar. So do this assignment. I hope you guys are doing well, and I will talk to you later.